I'm Yusuf. I work in TE as a software engineer. I work mainly in the card payments, but I also like to work cross teams as well. I'm here for like almost 4 years, and overall I have like 6 years of experience in software engineering. The stuff that I'm going to talk about now is not because I'm a Flink expert, but it's because I think I can capture like a cool story about a company that tries to adapt Flink, and there's nice parts about like the developer experience you can create around. As I said, feel free to ask questions, feel free to deep dive. If I can't explain things, I'm gonna forward you to the Flink official document. So let's start. The problem. So let's do this in the correct way, right? You don't choose the technology, then the problem. You choose the problem, then you choose the technology. You solve problems, you don't finish your technical fantasies. So in Teia, we process millions of payments every day. And by payments, what I mean is card transactions. When you tap your, I don't know, phone into the terminal, it's a payment. And in payment scope, the fraud is like a big problem because when fraud happens, you lose money, you lose company. So fraud is bad. I don't know if I had to make this disclaimer. Okay, so there's like some things that we detect, and I realize it's a bit hard to read. Maybe is it? Okay. So we track unusual transaction volumes. So if a guy that's normally selling, small grocery items tries to do like £1 million, yeah, that's fraud, of course. Regional anomalies, because the TPV is kind of dependent on the country. You have differing transaction volumes based on country. High refund ratios is like refund is when you get your money back, and if the merchant is doing that too much, maybe they are a bit fraudulent. When there's like suspicious payment methods, if you have a guy with terminal that's tries to do like e-commerce transactions, that's a bit of a question mark. Settlement discrepancies and chargeback spikes, they are also kind of identifiers of fraud. So as you see, this is like just a sample, but there are like 6 different fraud signals, and we need to compute them in real time because if you send money over to a fraudster, you lose the money. So it should be like fast. Why Flink? This is quite a legitimate question because Flink is not the only solution. Flink is like one of the millions of solutions out there. Before then, we used to write like normal Java Spring Boot applications with Kafka consumers, database connections, etc. Like the classic, what we call as a service. That worked well. That worked for quite some time. We recently started adopting Flink, so it's going to be easy to answer this question. It's because, first, Flink is simple. Flink is a framework. Flink is, if you know what you're doing, it's pretty simple. So in this code example, I have a transaction events, let's say, right? This is just a variable. I'm not talking underneath. Then you union this with refund events, and you do some partitioning over the data stream. If you are familiar with Java streams, this shouldn't be like a weird or alien technology, right? It's like code, and more code. And then you process this. Yeah, standard Java pattern, you just do method chaining. The cool part, this is a bit like iterative over like what I just said. You write and define your business logic, how you process stuff, how you filter stuff, how you map stuff. Then there is this partitioning, the key selection that I'm gonna talk a bit deeper because it's like one of the core things that what makes awesome in my opinion. And you write configuration, like since most of the things are in the framework sense, like you write the configuration, you don't do boilerplate. Okay, this is a strong statement. You do less boilerplate than usual. And inside Flink, you have state, which is the most important part. Like, it gives you state out of the box. You don't write data layers, database adapters, etc. It's fault tolerant up to some level, right? As I said, you need to configure things to get all of this beautiful good sides. It's scalable in most cases. Like, everything I say is like kind of optional, as like in the software engineering, right? Nothing is good or nothing is bad. Everything is great. And in this one, I even like make it explicit. It can do exactly once delivery. It has this semantics, but you need to configure for it. Below, I have like a simple diagram that basically you have like two streams. You can think stream as like a Kafka topic, a RabbitMQQ, or like whatever source you want. Then you filter them, you map them, you union them. So this is like a simple stream join. You process this data coming out, and conditionally, like, you send them into a sink. Super common use case is Kafka topic, and Kafka topic here. So it's really common to work with Flink in environment that you read from and you write to Kafka topics. I'm saying a lot of Kafka. This is another one. This is kind of sampling what I described in the business problem, right? You have your source topic, then you have like a small event router that you route things into transactions, refunds, settlements, and chargebacks, like different domain types. And in transactions, you do even more splitting. Then everything goes into processor, and processor has the business logic that it decides if it should sync into Kafka topics. All good up until now? Make sense? Amazing. Because we are getting to the problematic part now. Yeah, okay, let's go with Flink in action. We gonna do like a simple fraud signal pipeline. I know this is like super common example. It's even in the Flink's own website, it's like it's fraud detection. I'm not copying over the same, so. Okay, so this is similar to the code example I showed. We have a variable raw transaction stream, we filter and we map. And the cool thing is, like, the raw transaction stream, the variable, is a Kafka topic. It's a live object you can imagine. Then we do some pretty logic on top of. We map them into a common data type. So Flink uses a lot of generics. It's not that I'm a favorite, and it's not my favorite to use generics in this level, but it uses a lot of them. So we map both of the flows into fraud signal events, right? So we can have like a common ground in between. Then in this part, we basically union them, we do partitioning, we do process them. Since I explained this in the example, I'm not going over again. The interesting part here is, like, in the end, is if you see, like, we are mentioning a name and UID. And they are basically, one is for debugging. The name makes it a bit prettier. When you debug stuff, you can understand what you are looking at if you tag them by name. And UID is important when you do state migrations. So when you do changes in your processor, you don't lose the state that exists previously. Yeah, like, this part is where it gets deeper, because we said state migration. I'm not gonna go deeper in here. Like, I want this to be a bit higher level. But if you want, you can see the Flink documents about how state migrations happen and why it's such a big deal that makes Flink like a key component for quite a lot of big companies. And it's like, there's a lot of big companies using it. I think Uber is like a big user, and Alibaba is so much of a big user that they had like their internal version of Flink that's quite modified. Next one, yeah, the processor. And yeah, I don't have the animations for this, I forgot, I guess. It's not that complex. as you see, we extend from a keyed process function, which exactly what it says. It's a process function that is keyed. So before using this, we need to do the key by in here. In this process function, we have a process element function that takes an event, has some context object that you can do cool stuff with it, and it has a collector that's depending on your use case that you can send things through. So it's still stream, right? If you want to keep the stream going on, if you want to send stuff down the line, you just use collector to push things out. And as you see here is like in end, we do out.collect and we map the current state object into a model that to be sent down the line. Okay, another cool part, a critical part of the Flink as well, is state here. I'm going to explain a bit more in the next slide, I think, because this cut down to just show the business logic. But literally you have state, you do get state by, like, you get the value of the state, you do modifications, you do update the state, and that's it. Like, you don't need to write anything specific for database. You can choose your provider of how you want to store things, but like by default, if you put this out, it's gonna work. Like, you don't need to do any database connections, etc. This literally just as it is, it works. Okay. I kind of realized that I assume that everyone gonna understand what is a map state, but can you take a guess? Like, what can it be? A map state? No guesses? It's just a map, like the classic Java interface. And in this example, I'm not using map state, right? But I don't have like an event identifier as well when I fetch the state. So how this thing works? It's basically because we did keying. So keying means like you, okay, how much of you are familiar with MapReduce, the Google paper? Okay, amazing. It's literally the reduce part, I think. You have some values that has keys. And when you see the common keys, you forward them into common task manager, common processes. So imagine like this stateful one process only receives key A, B, and E, and like the other one receives only D, A, and Z. This simple logic gives you ability to be able to write code without worrying much about state modifications, because when you write it like this, right? And since you keyed it like this, all of your data that's available into your processor gonna be keyed by a a merchant identifier and a currency. So it simplifies the business logic side a lot, because you can cut down a lot of stuff that will be a problem if you don't do keying. And the downside of it is, of course, it's a bit harder to understand if you are not familiar with Flink, because the keying mechanism is kind of a unique thing, in my opinion. Then we have like a little part about state management. I'm not gonna go too deep on top of it. But as you see, we are defining a state configuration. That this one is defined specifically for setting a time to live. And in here, we have 2 hours as duration. And this set update type, it makes it like, if you modify the document, it resets the time. If you don't modify for 2 hours, it deletes it. There is some more configuration to optimize the save points, because the states can grow quite huge, sometimes 2 terabytes. And it's important to be mindful about what you store and how long you store, right? With this kind of small tweaks, you can get like big savings. And in the part of acquiring the states, it's also pretty simple. You set a descriptor for your state. It's literally just a unique name for the object you want to use. You set like the setting for TTL, And then only thing you do is like get runtime context.getState, and that will give you a checkpointed state that acts like a normal Java interface. In this case, it's just like a value, but you can have like a map, or you can have like a set, etc. That's semantically straightforward to use, but underneath it provides you like a lot of like benefits. Yeah, this is super hard to read because I made it in like the common sense and it's too close to the background, but yeah. So what Flink handles, I think I talk about all of it, right? Partitioning, checkpointing, whenever your job fails, and it does fail, believe me, like we're in a cloud environment and stuff dies randomly. And it can do automatic cleanup by itself, like you don't need to specifically write things into it. There are some edge cases that I wanna talk about that I don't remember how many I write down here, so let's see. Oh yeah, that one is cool one. This one for idempotent event processing. So if you are familiar with events-based, in like event-based system, right? And especially if you are doing like change data capture, you usually have like duplicates. Not in a sense that you consume a single event multiple times, but like there is multiple events that's representing different changes of the data. And of course, as like in our use case, sometimes you don't care about the change and like you just want to skip them. For this, we did like a super dumb solution, to be honest. We have a set of strings that are representing the IDs that we process. And if we solve the ID, we just ignore it. It works. Still works in production, so I guess it's like okay solution. Okay. Yeah, I think that was it. I'm thinking if I had any more things to go. Okay, so eventually we had one edge case. The testing. So this part is more about what we did to embrace Flink in the organization, because up until now I was mostly talking about what is Flink and what is capable of and how to use it. This one is going to be a bit more about like how we adopt it and how we make it easier to work with. So we have a couple problems with Flink. I mentioned that it was using a lot of generics. A lot of generics means runtime problems. Sometimes the code compiles, but it doesn't work when you push data into it. Sometimes serialization is a runtime concern, not a compile time concern. And even in some cases, like you mess up the schema registry and like the Avro models, and like you don't realize when your unit tests are passing, but they actually don't work. So for Flink, you need to do integration tests. Like it's almost non-negotiable. You need the running instance being tested before sending anything to dev or production. Yeah, there's a bit of a challenge. Like the Flink is like stateful, asynchronous. You have like a lot of logic in there that might mess up, especially because of generics. That's a bigger problem because it does work on a lot of assumptions, and if one of them is wrong, sometimes your entire job goes down. Sometimes your output depends on your event ordering and timing. That's for more extreme use cases that like you are really concerned about the events and out-of-order events. As I said, this is like much deeper context, so I will suggest you to look into Flink documentation. It has a section about the concepts and it explains the event timing. It's gonna make much more sense than if I try to do it now. And Flink is like a distributed system, right? By design. So how you do integration tests for them? And the answer is not hard. Is actually an ideology that you might already have like in your applications. Is that you don't test Flink, you don't test the technology, you test the behavior. You make it abstract enough that it works with real technology, but like it doesn't depend on what's underneath. In our setup, question? No? Okay. In our setup, we are using test containers that spins up like our dependencies, Kafka and schema registry in this case. Then we have like integration class space that runs our Flink job and provides some useful tooling like mailboxes that I'm gonna explain a bit more as well. And then of course we have our like component that we want to actually test, and the test cases that we have. This is gonna be much easier to understand when we look at the code. Okay, mailbox pattern. I realize this is kind of pointless. It doesn't explain much. So I'm gonna show it to you directly in the test. So in the test, you declare a company ID. This is like what we use to identify merchants. Then you create a new transaction. This transaction is an e-commerce transaction in success status with like some amount, right? It's like €1 million, let's say in this case. And the last one, you send this through Kafka. Of course, we have some synthetic sugaring behind that. When you construct the transaction message, it knows where it to send. It doesn't need explicit declaration. And then for the result, this is the part that the mailbox is cool. You literally say mailbox that inbox cross signals 1, and you drain for this specific key, and it waits for a certain time for this event to arrive. And when it arrives, like you just do validations on top of it. This makes it like tests really readable. Like if I have a new person joining to the team, I can like literally say, okay, go look at the integration test. You will have like an idea about the business logic, at least the important ones. And at the same time, imagine a feature that we wanna move away from Flink, or we wanna, I don't know, replace with other technology. This test still works, like, because it doesn't use Flink. Like the only assumption it does is that the application underneath uses Kafka. And as long as that assumption stands, like this can test anything with the same business logic. There is a pretty cool story of one of my coworkers that he was migrating a Kafka Streams application into Flink. And essentially he wrote the test in this manner for Kafka Streams. And in the end, like he didn't need to change anything in the test almost. He just changed in the base to spin up a Flink job instead of Kafka Streams. And the same test worked, same test passed. And with that, he had like he had enough trust in the Flink code base that he can like roll it to production. I think that's it. Yeah, I have this animation that I don't need now. Yeah, this is a bit the background of it. Before every test, we start the dependencies, we register the schemas needed. We set some environment variables depending on the test case. Of course, if you are testing something that is out of normal, sometimes you need to mess with these. You kickstart the Flink job and you clear the mailbox to have like a clean start. And that's just it. It's like a lot of syntax sugar in behind, but to be honest, it's like super pleasant to read in my opinion. Way it works, exactly what I said. I'm skipping that part. The trade-offs, they are slow, of course. They require Docker. That's I have problems time to time. My Mac is a bit old. I'm calling out to replace my PC. Flaky if timeouts are too short, and it's resource intensive in the same as like requires Docker. So this is like our idea in general. Unit test the processors directly, integration test the full pipeline. Because like for unit level, you don't need this much setup, and probably you need to test more edge cases that it's not worth to create like 10 integration tests. This part I'm gonna skip a bit fast. For local, we just use Docker Compose, and you can run your job in this way, but also you can put it as like a Docker Compose component as well. For Kubernetes deployment, Teya is running on cloud mostly, and we have our own Kubernetes deployment with is mostly provision. And to make the switching to Flink easier, to make people more comfortable, we created a custom Helm chart. It's more or less like a wrapper on top of the official one. It contains a bit more defaults and opinions, let's say in this way. In here, you basically define what is the version you want, the state backend that you want, availability types. You define the resources that you want. This is important because to handle more load, you need more resources. And there's upgrade modes that's in save point in this example. I forgot what was the other one, but again, you can look at documentation. The same Helm chart also provides you production alerting. So you can define what Slack channels that you want to be alerted on, and we use Opsgenie, which Opsgenie teams that you want to alert when something goes wrong. And in the Prometheus rules, you can define what you want to alert on. Of course, this part is truncated just to the names, but you define what is the alert premise, right? For managing configuration, we use a straightforward solution. Have a properties class, get environment or default, and set all of them into configuration. This code example is shortened a bit too much because it's long by its nature. But yeah, that one is I don't remember why I put this, but of course we don't change anything in between environments. In your local dev or production, the same code runs. Only difference is you change the configuration. As an example, you don't run as big machines as in production in dev. So another really cool thing that we did is creating a cloud code skill for Flink. I will say it's pretty useful when you need a second pair of eyes to check stuff. Because personally, I miss a lot of stuff time to time, and this helps a lot. Yeah, exactly. When you do something dumb, it tells you. And all of the things that I explained, we packed it into a single repository, a single template. That's in the internal developer portal. You can just say choose this action and create a new service. And I think our speed to put stuff in production right now is less than a week, maybe 2 or 3 days. Over this time, what we learned, build a template, it makes life easier, it makes easier to distribute good practices and bad practices. That's the downside. But yeah, it's you need to test how you deploy. You need to have this proper integration test and proper environment, so you are comfortable with what you are deploying, right? I don't think anybody is comfortable deploying stuff that doesn't work in dev to production. Yeah, about Mailbox. This is an important one. It's not about Flink, it's about in general in engineering. When you do something, monitor it. When you do changes, monitor it, be aware of it, set alerts, have nice shiny Grafana dashboards. Not just that you brag about them, but they are actually really useful. If there's weird patterns, you can catch them quite easily. And yeah, I mean, the context of the entire slides is Flink in this case makes it easy to develop this kind of stream processing faster and reliable, and it gives you enough of a framework that you actually don't spend much time on the technology, but you deal with the business. Thank you so much.